Hi guys. So today we're going to look at transformations of functions. Now the Desmos activity that we did in class was kind of a good start to show you visually what's happening with these graphs, but now what we're going to do is we're going to look at the algebra behind it and what's actually happening with these numbers to make these graphs do different things. So to start, we're going to use this graph here. And if you look, the points that are listed in this table are the points that are on that graph. So what we're going to do is we are going to apply these transformations and see what this actually does to the points that are on the coordinates of that graph. So the first transformation is f of x plus 4. Well, we know from that Desmos activity that that should shift our graph up 4. What that's actually doing to these points, we know that x is -1, and this tells us we're doing f of x plus 4. So we're going to take f of x and we're going to add 4. So -2 plus 4 gives me a new y coordinate of 2. So the new point here that I'm now plotting is -1, 2. Same thing on the next one. I add 4, so 2 plus 4 is 6. So 1, 6 is my new point. -2 plus 4 is 2, so 3, 2. And then I add 4 to that last point, and that gives me 6. So 5, 6. When I connect those dots, I can see it's the same graph that has been shifted up 4. Now, it's a little bit different when we look at horizontal transformations. So horizontal transformations, let's look at what's in the parentheses. All right, so that f of x right there, that's my y coordinate. So this is not affecting the y coordinate in any way. The original point on here was -1, -2. So if I still want to have that y coordinate of -2, because that has not been changed, there is nothing happening over here that's changing that point. What I need then is something to go in that parenthesis, something that's going to replace the x there so that what's in parentheses ends up as -1. So what I need then is for x minus 2 to equal -1. The value that would make that happen would be +1. So if x were to equal 1, if I were to, under this transformation, if I took 1 and I plugged it in there, then I would get f of -1. And I know that f of -1 is -2 because that was the original thing on there. All right, so same concept on the next one. What x would I have to plug in to the parentheses there in order to make what's in the parentheses equal 1? So if x minus 2 is equal to 1, then x has to equal 3. All right, on the next one, I want that parenthesis to be 3. If I want it to be 3, the value I would need to plug in is 5. On the next one, same thing. If I want what's in the parentheses to be 5, the value I would plug in is 7. Also, I think I missed a negative here on the notes, so that should be a -2 right there. So now I'm going to go ahead and plot those points. So I'm going to plot 1, -2, 3, 2, 5, -2, and 7, 2. So we can see it's the same graph, it's just been shifted to the right. All right, then this last one on here, it's just going to apply both a horizontal and a vertical change. So let's look at horizontal first. So I would need to plug in a value for x so that what I just underlined, that part, equals -1. So I want 1/2 x to equal -1. In order to do that, I would multiply by 2, so the value that I would plug in for x is -2. Then for the y coordinate, what changes that y is this negative on the outside. That's going to change that to +2. All right, let's go ahead and just finish our x coordinates. So the x value I would plug in order to make that equal 1, the x value I would have to plug in is 2. In order to make it equal 3, I would have to plug in 6. In order to make it equal 5, I'd have to plug in 10. Then my y values, I'm just going to make those negative because it's a negative f of x. So that's -2, +2, and -2. So -2, 2, 2, -2, 6, 2, and 10, -2. So there's my graph. It has been stretched horizontally. So you can see that that graph has gotten wider. The height of that graph has not changed, but we can also see that that graph has been reflected over the x-axis. All right, so this little chart here is just going to summarize all the things that we did in the Desmos and some of the things we just talked about. So f of x minus h, that is a shift to the right. So if we see x minus a number, it's going right. If we see x plus a number, it's going left. A number multiplied by the x, it depends on the value. If it's greater than 1, then that is your horizontal compression. It is backwards from what you think. If it's between 0 and 1, that is a horizontal stretch. And then if we make it negative, then that is a reflection over the y-axis. So algebraically, what that's doing to our points, if we are shifting it to the right, then we're going to take our x-coordinate and we are going to add the value of h. Going to the left, we're going to subtract h. Since we are doing the reciprocal, we are dividing by b. So if it was 1/2, we would do x times 2 because dividing by 1/2 is multiplying by 2. And then for reflections, we're going to make the x-coordinate negative. So everything on that left side is horizontal, and that is affecting the x-coordinate. The chart on the right, that is all of our vertical transformations. So f of x plus k, that's going to be a shift up. F of x minus k is going to be a shift down. If a is greater than 1 and it's multiplied, that is a vertical stretch. And if 0 is less than a, which is less than 1, that is a horizontal compression. That negative out in front would change it vertically, which would reflect it over the x-axis. So algebraically, what this is going to do, these are going to change our y-coordinates, and it is going to be the same. We don't need to worry about changing anything. So we're going to add k to the y-coordinate if it's going up. We're going to subtract from the y if it's going down. We're going to multiply, and we're going to make it negative. All right, so what we're going to do is we're actually going to apply transformations to one specific point. So f of negative x, that is a horizontal change. It's going to be a reflection over the y, so that is going to make the x-coordinate negative. B, that is a vertical stretch, so that is going to change our y-coordinate and multiply it by 2. C, that is a shift left, so we're going to subtract 7 from the x-coordinate. D is also a horizontal change, that is a horizontal stretch. So remember, we are dividing by 1/3, which means we are multiplying by 3. On D, there is both a horizontal change and a vertical change. So the horizontal change is going to affect the x-coordinate. So 2 plus 1 is 3. The plus 3 is going to affect the y-coordinate. 3 plus 3 gives me 6. Same thing on E, there's both a horizontal and a vertical change. So the horizontal change would be a compression. So I would do 2 divided by 2, which gives me 1. And then I would have negative 3. On F, now this is when we have multiple transformations on the same coordinate. So let's go ahead first and do our x-coordinate. All right, so our x-coordinate, we've gone left 2, so we're going to subtract 2, so our new x-coordinate is 0. On our y-coordinate, there are 2 transformations. There's a vertical stretch of 3, and we're also shifting down 4. So what this means is that the order is now going to matter. All right, so what we're going to do is we are going to multiply first, and then we are going to subtract 4. So we're going to do 3 times our y-coordinate, and then we're going to subtract 4. So 3 times our y, which was 3, so that's 9. 9 minus 4 is 5. So with vertical, we can always multiply first. Now, when it comes to horizontal with multiple transformations, if you want to be consistent and multiply first, you have to factor out anything that's in front of that x. So I need to rewrite this with that value factored out. And again, the reason I like factoring that out is just because, 1, it keeps it consistent, but 2, factoring out that b value is something that you'll have to do when you get to your trig graphs next year in pre-cal. So it's kind of a good habit to get into. All right, so what I'm going to do from here, let's go ahead and apply our horizontal transformations. So I'm going to divide by negative 2. So I'm going to do 2 divided by negative 2, which is negative 1. Then I'm going to subtract 2 because I'm going left 2. So negative 1 minus 2 is negative 3. Then let's look at our y-coordinate. So I would take 3. I'm going to make it multiply by a negative 1. So that's negative 3. Negative 3 plus 2 is negative 1. And that's my new coordinates. All right, this next section here, we didn't finish all of these in class just because it's the same process we just did, but we're applying it to multiple points. But I do want to just go through a couple of these for you. So on A, that is a reflection over the y and a vertical stretch by 2. So what this would do to those points, we would take each of those points and I would have a negative x coordinate and then I would double the y coordinate. So on that first one, negative 3, 0, I would reflect that to 3, multiply by 2, still in the same place. I would take that negative 2, 1 point, I would make it negative, which would reflect it over here, then I would double it, which would move it up there to 2. I would take this point right here, so 1, negative 1, negative 2, I would reflect it, so it's 1, negative 2, then I would double it, and it's at 1, negative 4. So again, I'm applying that same transformation to every one of those points. 0, 0 is still going to be 0, 0. 1, negative 1 gets reflected and doubled. And then 2, 2 gets reflected and doubled. And now I can connect those points. So I'm going straight line, curve, straight line. So you can see it's the same graph, but it's been reflected over the y and it has been stretched by 2. On B, what I'm going to do is I'm going to tell you the transformations, and then I'm just going to say how we would affect those coordinates. So this graph has gone right 1. It's been reflected over the x-axis, and it's gone up 2. So what that's going to do to each of those coordinates, it's going to be the x-coordinate plus 1, and then we're going to take the y-coordinate, we're going to make it negative, and then we're going to add 2. All right, for C, again, I'm going to get in the habit of factoring out that value. So vertically, the only vertical change is going down 1. Horizontally now, I am going to have a horizontal compression. And then after that horizontal compression, I'm going to go left 1. If you did not factor out that value, then those numbers are going to look a little bit different. So what this is going to do to our x-coordinate, I'm going to take my x-coordinate, I'm going to divide it by 2, and then I'm going to subtract 1. For my y-coordinate, all I have to do is subtract 1. And I would apply that to each of those points, and then we would see our transformed graph. If you want to see the completed graph, you can check the filled-in notes on Schoology, and that will show you what that graph would look like. All right, so now what we're looking at are our parent functions. So when it comes to transformations throughout the year, we are going to apply those transformation rules to each of these different parent functions. Some of these you may have seen in Algebra 1. So we're going to start with the constant parent function. So that B value can be any number. The constant function is just y equals a number. The linear parent function, y equals x. Quadratic is y equals x squared. Absolute value. So absolute value, if you have not seen that, it's those straight bars. And what absolute value means is just the distance that it is away from 0. So for example, the absolute value of negative 5 is just 5, because negative 5 is 5 away from 0. So basically any negative just drops. The absolute value of 2 is just 2, because it's 2 away from 0. Cube root has that little 3 on the root, so it means what number times itself 3 times. Cubic would be to the 3rd power. Square root looks like just square root x. Rational is when you have that x in the denominator there. We're going to use that a lot second semester. Exponential, you probably saw in Algebra 1. That base can be a couple different values, but the important thing here for the exponential function is that the x is in the exponent. And then finally the log function, which we'll look at the end of the year. So what we're going to do is we're going to look at a function that has transformations applied. So we're going to use what we've seen about transformations to just determine what the parent function is and what transformations there are with it. So on A, so the first thing we need to do is we need to know that is the absolute value parent function because it has those straight bars. Then we're going to see what my transformations are. So this x minus 3, anything that's within those bars is going to be a horizontal transformation. So this has been transformed by going to the right 3. That 2 out in front, outside of those bars, that's your vertical transformation. So this has been stretched vertically. Let me go ahead and put vertical on there. By 2. All right, and look at b. b is the cubic parent function. What's in the parentheses there, that is our horizontal change. So the only transformation horizontally is that it has gone left 1. And let's look at our vertical transformations. That negative out in front, that is a reflection over the x-axis. And that minus 4 is a transformation down 4. All right, now let's look at c. So c is a square root. Everything under the square root, okay, whatever is under the radical, that is what's basically your parentheses for this equation. So if it's under that root, then that is going to be a horizontal transformation. So the only horizontal transformation is that negative, which is a reflection over the y-axis. The only vertical transformation is that it has gone down 5. And then our last one, at least it's easy to see the parent function. This is a log graph. The horizontal transformation is inside here. This has a horizontal compression. So remember that 2 is a compression where you would multiply it by 1/2. All right, so then we have a reflection over the x-axis, and we are going up 7. So those are our transformations. All right, this next example, we are going to do the same thing but backwards. We are now given the name and we're given the transformations, and we're going to write the equation. Now, one thing about this is it does not tell you the order that you're applying those transformations. Now, once we do some more of this, then we are going to do, once we see order, that's going to affect our equations some. But for now, we are just going to look at having these transformations applied in some order. So the first one's absolute value. So I'm going to have these absolute value bars. Anything that is horizontal is going to go inside those absolute value bars. So shifted to the right, that is my horizontal transformation. So x minus 5. The vertical transformations happen outside of it. So if I have it vertically stretched and reflected, that would be a negative 3 out front. All right, quadratic. I've got my parentheses, and my parentheses will be squared if it's quadratic. The horizontal stuff will be inside our parentheses. The only horizontal thing I have here is left 6. So that's going to be written as x plus 6. Then I can see that vertical compression would be 1/4, and then up 2. Then my last one, square root. So shifted up 4, horizontally stretched, reflected over the y, and shifted left 3. This one has a lot of horizontal transformations on it. So any horizontal transformations have to be under the root. The up 4 needs to be after the root. So since this is being stretched horizontally, again, be careful, that needs to be 1/2. Because if I put 2, that's a compression, that is not a stretch. Since it's reflected over the y, I need that negative. And then since it's going left 3, I should have x plus 3. Now this is where, again, order starts to come into play. We'll talk about this more later this year, but I can have this, or I can put these parentheses to have those transformations. The difference between those two is what order those transformations are being applied. Negative 1/2 x plus 3 written this way would mean I would shift left first, then I would do my reflections and my stretches. If I put those parentheses on it, I would do the reflections and the stretches first. The last thing I would do is that I would shift left. All right, so again, the parentheses are really going to change what order you're applying those transformations in. Since this question didn't talk about order, either of those answers for here is okay. All right, so the last thing we're going to do is we're going to actually apply these transformations and actually graph an absolute value function. So in order to do that, we need to know what the parent function looks like. So remember, absolute value means how far away is that value from 0. So the absolute value of negative 2 is just 2. The absolute value of 3 is 3, because it's saying how far away it is. So what that means is this graph goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, so on and so on and so on for all those positive numbers. But when I get to negative x values, the absolute value of negative 1 is 1, because that's a distance of 1 away. The absolute value of negative 2 is 2, and so on in this direction. What's really nice about this one, it tends to get remembered pretty easily because it's called absolute value and it looks like a V. Just like with quadratics, this have a vertex, and that vertex is HK. So we're going to go ahead and graph this one. In order to do that, we're going to look at the transformations. So this graph has gone left 1 and down 3. What that means is that the vertex has gone left 1 and down 3. So that's my new vertex. What's nice is that your vertex is not really going to be affected by any of your stretches, compressions, or reflections, as long as you factor it out if there's something on the inside. Okay, but again, we do have to factor it out if there's something on the inside there. Now, since there are no stretches, compressions, or reflections, this graph is going to have the same slope as the parent function, which was over 1 and up 1 for every point to the right of that vertex, and left 1, up 1, with that slope of 1 or slope of negative 1 for every point on the other side of that graph. All right, on B, still an absolute value graph, but this one, besides moving the vertex, also has a stretch and a reflection. But even though there's a stretch and reflection, if I reflect and stretch 0, 0, it's still 0, 0. So then I would shift that point and go right 1 and up 4. So my vertex here is 1, 4. This graph also has been reflected, so it's going to open down. And then because of that too, it's been stretched vertically, that's going to change the slope of what's coming from that vertex. So instead of just going over 1 and up 1 for each of those points, I'm now going to go down 2 and over 1 for each of those points. And there's my absolute value graph. All right, last one. It has no horizontal changes. So my x-coordinate, my vertex is 0. It's been compressed and it's been shifted down. So my vertex is going to be at 0, negative 1. The slope of those lines coming off of it, though, is going to be different because of that 1/2. I'm going to be going from that point up 1 and over 2. And that is my absolute value graph. All right, so we're going to look at absolute value equations and inequalities over the next couple days, and we'll spend a lot more time looking at absolute value. But again, the biggest thing for today to really understand is how to apply those horizontal and vertical transformations to a graph.